Good morning, good afternoon, everyone, and welcome to today's instructional webinar for the NASA Space Robotics Centennial Challenge. My name is Jonathan Yakasha, and I am a program manager with 9 Sigma. I'll be your host and co-moderator for today's webinar. Please note that this webinar is being recorded and will be transcribed and sent to all the teams for review at a later date. At this time, I'd like to introduce to you my co-moderator, Shaka Jaliwa, who is an education specialist and project manager for the Space Robotics Challenge at Space Center Houston. Shaka, would you please walk us through the agenda for today's webinar?
I'm going to do my best, JJ, but I am a little nervous, so please have mercy on me. We here at Space Center Houston are very excited to be at this phase of the challenge, and we are looking forward to ushering you all into the qualification round. Let's dive right in, shall we? First, we'll provide the speaker introductions. Then we'll have some NASA representatives provide some background and an overview of the challenge. After that, we'll work through a review of the challenge rules, including eligibility, and then we'll discuss the specifics of the qualification round. Finally, we want to make sure that we answer all of your questions, and we'll review the ones that were sent in prior to the webinar today. If during the webinar you have questions that come up, please feel free to communicate those by submitting them through the Q&A box. And we will try to collect and present any unanswered questions during the FAQ section. If we don't answer your question live, don't worry. We will answer all remaining questions after the webinar and post them on the challenge forum and the transcription created from this webinar. Finally, we'll wrap up with the information on the next steps for moving into the qualification round. And now I will hand it back over to JJ to introduce our speakers for today.
Great, thank you very much, Shaka. Today you'll hear from several different speakers presenting information about this exciting challenge. We're pleased to welcome the following speakers. First, from the 9 Sigma offices here in Cleveland, Ohio, we have from NASA Centennial Challenges, Angela Herblay, Space Robotics Challenge Phase 2 Challenge Manager. From NASA Johnson Space Center, we have Principal Technologist Kim Hambikin. And we also have additional support staff from the Johnson Space Center to answer technical questions about the challenge. First up, we have Angela, and she's going to give us some background on the Centennial Challenges program and how it relates to the Space Robotics Challenge. Angela, please go ahead when you're ready.
Thank you, Jonathan, and thank you everybody who's here today. We appreciate your interest and we look forward to sharing all this information with you. Next slide, please. So as Jonathan said, I am with NASA Centennial Challenges, and just to give you a bit of background on us, we were NASA's first and we are the biggest prize program within the agency. We were established to conduct prize competitions in support of NASA programs and missions, and we took inspiration from the Orteig Prize and the Ansari X Prize, among other, but they influenced how we build and formulate and structure our challenges. And we do operate under the NASA Prize Authority, so there are some requirements that come along with that, but they did give us the mission of stimulating innovation in basic and applied research, technology development, and prototype demonstration that have the potential for application to the performance of the space and aeronautical activities of the administration. So basically, we were tasked with going out, finding the innovative solutions that could be integrated into NASA missions and actually be applied in real ways. Next slide, please. So you may have all heard, because it's been in the news, it's been kind of all over, that we are going back to the moon and then eventually on to Mars. So here we have a quote from our administrator, Jim Bridenstine, who has been the forefront of this talk around this mission of going to explore the moon and then on to Mars. The biggest piece, or the biggest highlight I want to point out here is towards the end where it says, this time when we go to the moon, we will stay. And then we'll take we will use what we learn on the moon and take it to the next step. So that's really what this challenge is about and the inspiration behind it. And if we go to the next slide, you can see that we've mapped out kind of what we need to do in order to be successful in both the lunar missions and onto the missions on Mars. So if you look at some of these, autonomous operations, sustainable power, in situ resource utilization, And the list goes on and on. So just a few things we need to take care of before we can get these missions underway. If you move on to the next slide. But that's really what has influenced NASA in all of our crowdsourcing initiatives. So you can see here that Centennial Challenges is just one of the many ways that NASA is looking to pull in solutions from really the world, bring those solutions in and help accomplish those technology gaps, or help close those technology gaps that we need to do in order to make the mission successful. Next slide, please. And so within Centennial Challenges, we do have a few challenges running right now. And I'm not going to spend a whole lot of time here because we definitely want to get into the Space Robotics Challenge. But you can see here, these are the active challenges that we have. So the two that are the most recent is the CO2 conversion challenge. Phase 2 has opened. They're looking to convert CO2 into glucose so that it can be used to make resources once we're on Mars. And then Space Robotics Phase 2, of course, opened, and that's what we're here to talk about today. Next slide. And then what do we have in the hopper? You may see the word lunar over and over, which makes sense. So the challenge that we have in development right now is around lunar nutrition and how do we fill the nutrition needs of our astronauts and explorers as they go onto the moon and also further into space exploration. And then you can see the other three here around sustainable power, excavation, manufacturing, construction, learning how to protect our planets and really make sure we're doing a good job of being respectful as we go and explore. Next slide, please. So the biggest message through all of these challenges is that we want you. So we need your solutions and your brilliant minds to bring forward the technologies that we're looking for in order to be successful in these missions and to carry ourselves to the moon in a sustainable way and then also onto Mars.
All right, thank you, Angela. As JJ or Jonathan, I call him JJ because his last name is very difficult to pronounce and I want to respect that, so I call him JJ. There are several organizations that come together to make this challenge happen. And you can see some of them listed here. So we have NASA Centennial Challenges, who is the challenge owner. That means they created it, they had the idea, they're putting up the prize money, and it's basically their baby. They are the parents. Space Center Houston is an allied partner. We're like the crazy uncle that just wants to make everything happen. So we're here to help with development and implementation. NASA Johnson Space Center is the crazy uncle's wife. She actually keeps him in check and makes sure everything works. So they design the challenge, they do all the technology behind it, they build and manage the simulation environment and models. They are the ones that make it work. If you go to the next slide, we also have some other people that are helping us out. BHP is the challenge presenting sponsor. They are providing financial sponsorship and they're looking to see how they could use what we learned through this challenge on things that they could do for terrestrial work. Then we have 9 Signal, who is the technical challenge facilitator. They basically make sure the lights get electricity, as it were. They get all the registrations and everything. They manage all the webinars. They make sure that you understand what we're trying to do, and they give us your information so that we can make sure that you can compete in the challenge. Army Corps of Engineers are consulting subject matter experts, and Sphero is a part of our STEM education and outreach team. So we have a few challenges that we're planning on doing with them for our students that are not necessarily able to participate in the Space Robotics Challenge. So those are those roles. And if you can go to the next slide. Now I'd like to hand over the presentation to Kim Hambikin from NASA Johnson Space Center to talk a little bit about the current state of the robotics program within NASA and what a successful Space Robotics Challenge would do for the program. So Kim, whenever you're ready.
Good morning, good afternoon, everyone. So I just wanted to give everybody a little bit of background on this notion of ISRU surface robotics. Because of this new lunar pivot, as we like to say at NASA, we're very interested in looking at how we can use robotics to do things that we don't necessarily think that crew will have time to do, and that may be more difficult for crew to do when they're on the lunar surface. One of these activities is what we call in situ resource utilization. And the idea is that we can actually use the resources on the moon to enable crew to live and work on the moon, both, and to also allow spacecraft to leave the moon and go to Mars. So one of the interesting things that we've found in the last decade at NASA is that there is water ice on the moon, along with several other chemicals. And so we would like to actually be able to extract that water ice from the lunar dirt and use it both to create oxygen for humans to breathe while they're working on the moon, to create water for them to consume, and to actually create rocket fuel to allow us to then maybe get off of the moon and go to Mars, which would be much less costly than trying to get to Mars from the Earth. So this slide is showing some of the different concepts we've developed for ISRU robotics. And ISRU kind of contains a whole host of activities, from the extraction of the lunar dirt to using the lunar dirt to actually construct habitats on the moon. So we have, and we would also like to do this on Mars one day, but since the lunar surface is our current focal point, we've decided to focus on that for this challenge. So the idea is that we would take these robotic systems, have them on the moon, working, extracting the lunar dirt, processing that dirt, maybe starting to build up habitats, all while we don't have human astronauts on the moon, so that we can start getting ahead of what we need for those astronauts to live and work once they do arrive on the moon. And unfortunately, the moon, the distance between the moon and the Earth is enough so that we still have some latency between when we send a signal from Earth and when it gets to the moon. So direct teleoperation of these robotic systems is not actually viable. And while we do know that we could likely do what we call supervisory control, so that humans are constantly monitoring these robotic systems and sending high-level commands, we would prefer not to do that, because then that means that we have a whole suite of people sitting on what we call console, spending their days and their nights managing these robots. What we would really like to see is for teams of robots to perform these ISRU activities on the moon. And that's where this challenge comes in. So next slide. So this Space Robotics Challenge Phase 2 is really looking at how can we create these teams of robots to autonomously complete these ISRU activities without any human intervention. We know that we currently don't have systems that can do this right now on the moon. And some of the issues that we have with current systems current terrestrial systems are that we can't just take the robots that we have on Earth and put them on the moon. Most robotic systems depend on GPS to do navigation. And most, if not all, robotic systems that can do any autonomous skills require the use of LiDAR. We don't have small weight and power LiDARs that can handle the lunar environment. Many terrestrial robotics also use terrestrial processing, which we can't just send to the moon because of the environmental concerns. And most of the robotic systems that we actually use and do technology development with today require some human input. And what we're looking at is teams of robots to do things autonomously without human intervention. So we think that if we can actually find some solutions through this challenge from competitors such as yourselves, that we can actually start establishing some mission architectures that will allow us to really utilize the resources on the moon to create better living environments for astronauts, and also to create cheaper ways to get to Mars. And if we have these robotic systems that can do their tasks autonomously, then we can actually allow the missions to kind of begin before astronauts get to the moon, and then continue on once the astronauts leave. And really, this is where I see one of the biggest gains that we could get, is that if we can create autonomous systems, autonomous robotic systems that can manage their mission tasks on their own, then we're going to actually be able to free up the astronauts to do even more exploration and science, because that's really what we'd like to use the people for. I'd rather not have an astronaut who's digging up lunar dirt and putting it in a processing plant when they can actually go out and be scouting science samples to give us more information on how, you know, the moon formed, more information on the solar system and the universe. So this is kind of the high-level overview of the background for this challenge and why we have decided to focus on lunar robotics in this ISRU type mission. All right, next slide.
Great, thank you, Kim. All right, now that you've all had the opportunity to hear about Centennial Challenges and the state of NASA's robotics, let's dig into the details for Space Robotics Challenge Phase 2. So there's a bunch of information on the next couple of slides. I won't read all of it, but just kind of give you the important details here. First off, on this slide here, you see the overall timeline for the challenge. We're here today on October 16th, 2019 for the informational webinar. The next really important date that you're going to want to pay attention to is the registration deadline, December 20th, 2019, 5 p.m. Central Time. So that's going to be a date that you're going to want to keep in mind. Overall, the objective of SRC Phase 2 is what it says there on the screen: to find solutions to allow a heterogeneous multi-robot team to autonomously complete tasks envisioned for an ISRU mission. What are you going to be asked to do, competitors? You're going to be asked to develop software that will allow that virtual team of robotic systems to operate fully autonomously to achieve that mission within a specific period of time. Of course, if you're going to be asked to do something, you're going to want to know what you're getting out of it. Here is some information as far as the awards. For the qualification round, and that is the first round where everybody that registers will be eligible to participate. You have a $375,000 US cash prize. The top 25 teams who meet or exceed a given threshold score will receive up to $15,000 US each and be invited to compete in the final competition round. Important caveat there: should a top 25 scoring competitor team not complete all of the required tasks, a percentage of that prize pool will be awarded based on the percentage of the trial that was completed. As I said just a moment ago, the top 25 teams from the qualification round will be invited to participate in the competition round. For the competition round, much larger prize purse. The top 10 teams will be awarded cash prizes, and you can see the amounts there. 6th through 10th place will each get $30,000 and a top prize for first place of $185,000. So, I'd like to talk a little bit about who is eligible. First and foremost, anyone 18 and over can participate in the Space Robotics Challenge Phase 2 as long as they are not a citizen of a country that is on the NASA Export Control Program list of designated countries. There's only a handful of countries, and if you have questions about that, that information is readily available for you. Additionally, anyone affiliated with a Chinese entity resulting in a prohibited bilateral relationship between NASA and China or a Chinese entity. Realize that you may have questions about this. If you do have questions about it, please feel free and welcome to ask questions via the info@spaceroboticschallenge.com email. We'll take down your information. We will consult with the challenge administrators and determine an answer for you. Now, who can win a prize? In order to win a prize, a competitor team must have a team leader that is a US citizen or a permanent resident. That is, by definition, under NASA Centennial Challenge's prize authority. So if you are interested in participating and would like to be able to win a cash prize, the team leader must be a US citizen. Non-US teams and non-US citizens are eligible to participate. However, they would not be eligible to win any cash awards. There are some exceptions on that for that are listed there. So please look those over. If you have any further questions, again, please feel free to reach out to the info@spaceroboticschallenge.com email. So let's talk about insurance. One of the requirements for participation in the NASA Centennial Challenge for SRC2 is that teams require insurance for the duration of the competition. As noted on the screen there, this is mandated by Congress as part of NASA's prize authority, meaning this is set in stone. It is what it is. If you're interested in competing, you will need to obtain insurance. The details for the insurance are listed there on the screen. As far as what type of insurance or where you get it from, that's really up to you. As long as the insurance coverage meets those requirements that are listed on the screen there, it will be acceptable. So if you have an existing insurance policy that can meet those, fantastic. If you need a brand new insurance policy that meets those requirements, that is what needs to happen. So if you have questions about it, and I imagine that you might, again, please feel free to reach out to us. Give us some information as far as the nature of your coverage, and we'll again consult with challenge administrators to verify that that is acceptable. Hopefully that has cleared up some of your questions as far as eligibility and insurance. At this point, I'd like to turn it back over to Shaka. Shaka, hopefully the attendees that are listening today have listened through these slides and said, yep, we're eligible and we're interested in participating. What do we do next? Could you tell them about that, please?
I'll do my best. All right, if you are eligible to participate in the challenge, then the next step would be to complete and return all of the forms in the competitor packet. You can download the registration packet from the challenge page, along with several other important guides and documents. The registration packet includes the team agreement, which each team member must read and sign, and an acknowledgement form for non-US participants, both students and non-students. In addition to submitting these forms, you will need to submit any required verification forms. For example, federal employees that participate are required to submit formal permission to participate from their supervisor. Additional information on this and other required verification forms can be found in the team agreement. Once the team leader has submitted all of the completed forms via the online registration form, the challenge administrators will review the forms to verify their completion. Once verified, the team leader will receive a confirmation that your team is eligible to participate in the qualification round. You will only receive that information after you have completed and returned your forms, and the challenge administrator has verified them. Along the way, if you run into any questions or if you'd like to communicate with the community, please feel free to reach out through the challenge forum or by contacting the challenge help desk. I encourage you not to delay in sending your forms in. Consider this your reminder that no registrations received after December 20th at 5 p.m. Central Time will be processed. So start working on your forms early and give yourself plenty of time to complete them. Next slide. And now let's get into the meat of the qualification round. And for that, I would like to hand things over to the NASA Johnson Space Center team. Take it away.
And actually, Johnson Space Center, before you proceed with your component for today's webinar, I'd like to reiterate to our attendees, this is an excellent opportunity for you to ask questions about the challenge to our assembled guests of experts here. Please avail yourself of this opportunity. As was mentioned previously, if we don't get through all of the questions in today's session, don't worry. We're keeping track of the questions. Any questions that we don't get to during the Q&A portion of today's webinar will still be answered. It'll be included in the transcript. So even if we don't get to your question, don't feel like you won't get an answer. You will get an answer. It'll be part of the transcript. Should you think of a question outside of today's webinar, again, you can contact the info@Space Robotics Challenge email to ask those questions as well. Excuse me, JSC, please proceed.
Morning, everybody. Brief overview on the qualification round. So the qualification round will be broken up into 3 tasks that will be performed on the lunar surface. That is resource location, resource collection, and the self-localization of your robotic teams. This round is intended to be a reflection of the competition round. So this qualification must be completed before advancing. One thing important note to take away here is that for this qualification round, the competitors will run the simulation on their local computer. Next slide, please.
So for this competition and the qualification round, we will provide a gazebo simulation environment that will help with the development and testing, and also provide the API that will be used to communicate to the robotics team, the virtual robotic team. There will be 3 individual tasks as mentioned before. One is resource localization. In this task, the main objective is to search the lunar surface for within the predefined area the resources, and also report the location and the type of the volatile that is found. The second task is resource collection. In this stage, the objective is to collect specific amount of the resources. And then the third task would be to self-localization. This will be the objective of this task is to report the location of the object that we like to find, and then return back to the home base. If you go to the next slide, each task has a point system to know how much one team can have. And so for the qualification round, you guys can practice as much as you want. It's going to be run on your local computer. And so once you have a good simulation code, you can submit the log files that will be output of the simulation. And each, as most of the time, there are different point system based on the task. So for resource localization, there's 2 points for locating each resource location. So there are many type of volatiles that will be part of the sim, and for each volatile, there are points associated with them. For the second task is the resource collection, and in this task, the scoring is 1 point for the minimum amount of each resource being collected, and 1 point for each additional multiple of the resource collected. There's 2 points, extra 1 point if you do find it in the permanently shadowed region. For the third self-localization, it's 5 points to accurately provide the location of the object that we'd like you to find, and then 5 points to getting back to the home base. And there's extra 3 points if you do correct alignment when you come back to the home base. And the log files will be evaluated by us, and the top 25 competitors that has the highest scores will submit their software to be run on the host computer here for verification. If you go to the next slide. So the output of all these qualification round will be ROSBAG, and there could be some other file format, and the competitors will be uploading that result package back to us for evaluation, and details for time synchronization for the launch files, and all the gazebo metadata and gazebo launch files will be provided to the competitors to do their qualification round. Teams will have 2 weeks from the date of formal request to submit their code. And like I mentioned, 25 top scoring team will be asked to submit their simulation code for verification. Go to the next slide.
Just some important dates here to keep in mind. After the registration closes, the competitors will be provided with a packet of information, robot information. That'll be in January, and in the February timeframe, we'll provide additional information that will be containing instructions on uploading your qual runs to do for scoring, and also some information containing the simulation environment. Next slide, please. For the competition round, the competition round will encompass all the tasks that were completed in the qualification round, and of course, these were necessary to perform and complete a long-term autonomous ISRU mission. The objective will be to collect as much lunar regolith as possible. And one distinction between this and the qualification round is that unlike the qualification round, these runs will be performed on a field computer as opposed to your local computer. Next slide, please.
So for this also, the simulation and all the API will be provided. It will be listed in a wiki format. The competitors will have a spreadsheet with all the robotics team characteristics, such as the speed, what type of sensors, anything that is related to the virtual robotics team and the sensors. And you guys will be tasked to come up with your own robotic virtual team that will meet the criteria. The main criteria will be the mass and the power constraint. The difference between the competition and qualification is that this will have some degradation effect as part of the competition as it runs. So there will be degradation of the parts failure. There could be recharging that will be required for the virtual robotics team, and also maintenance. The software, this competition covers most of the qualification round that were done prior, so that you have a good understanding of how to design and develop the code to have a continuous run for this part. And competitors will be provided with access to online repository for downloading and practicing the simulation world prior to the competition is done. If we go to the next slide. And so since this part of the task will be done on the cloud, competitors can practice on their own computer in the beginning, and then we'll have a dry run session where they can import their software into the cloud to run online. And after that, once the runs will be completed, the points are given based on the criteria that are set for the competition round. And so in this task, it's not just collecting the regolith or the volatiles, and then the task is to process them. So the teams will be able to excavate, haul it to the processing plant, and place it inside the processing plant, and that's where the scoring comes in. And you guys, all the competitors will be allowed 3 runs, and the average of all those 3 runs will be the final score for the competition. And if there's a tie during the final scoring, there are 4 different criteria that will be used to break the tie. Basically, the first one will be whoever has the least combined mass for the whole virtual robotics team will be the first. Second would be the point value of all the resources that are in the hauler at the conclusion of the round. Third would be the number of resources types that are collected at the conclusion of the round. And the fourth will be the number of original robotics team members that are still performing their intended function at the end of the round. Next slide. The delivery for this competition will be the source code that will be used to run on the cloud. And so the configuration form will be provided that specify all the different virtual robotics team and all the characteristics of the sensors and the robots. Final simulation code will be uploaded, like I mentioned. Details about the synchronization and all the launch files will be provided and will be on the wiki. One of the things that we like to get from the competitors is the electronic summary containing the CONOPS, the results, and the lesson learned. That would help us develop better simulation and also help NASA with the any other challenges that are part of the virtual robotic autonomous competitions. The template will be provided by the website, the challenge website, and yeah, so that's about it on this slide.
Just some more important dates here as they relate to the competition round. You'll see some dates here that we stated previously for the qualification. One thing to note is we'll be providing this, resolving this CBD that you see here shortly, but we do expect this that this will happen before the competition closure. So just important dates to keep in mind about when the competition round opens and how it relates to the qual round. Next slide, please.
Great, thank you, JSC team. Now it's time for some frequently asked questions. These are questions that have already been asked, either in webinar registration or through the challenge help desk. If you have further questions about this challenge, please avail yourself of the Q&A chat box to submit your questions. Following this Q&A period, we'll take the rest of our time to answer them live. As I've stated a few times, if we don't get to your question during today's webinar, don't worry, we'll have information provided to you as part of the transcript. One note that I would like to say, we're going to focus on technical questions for the challenge. Questions regarding individual eligibility for the challenge will not be addressed as part of today's webinar. We'll get you the information. Send in your details regarding your questions of eligibility to the info@spaceroboticschallenge.com email so that we can collect that information and make a considered determination, as well as for insurance too. With that in mind, we'll proceed to the FAQs. Angela, would you please ask the FAQs?
Yes, so you set this up perfectly. Who do competitors contact with questions? And also, what is the preferred communication method for the challenge?
Excellent, excellent question. Very important to be able to get your questions answered. If you have questions regarding the challenge, please send them to info@spaceroboticschallenge.com. That is the preferred communication method. That way we can get the information from you regarding your question, regarding any additional information that you have about your question, and then we can consult with the challenge administrators and provide an answer to you. It may take a little bit, depending on the complexity of your question, to get you those answers. So we'll thank you in advance for your patience while we determine the best way to answer your question.
Thank you. Next question, should teams create a website to promote their team, and will anyone be interested in that?
Well, that is really a question that's up to the teams. During phase 1 of Space Robotics Challenge, some teams did create Facebook pages for their teams to promote what they were doing. Others did not. So it's really a judgment call for that individual team. Will anyone be interested? It's a possibility, especially if you do well in the challenge. So it's really up to the individual teams on whether or not they want to take the time to devote to that.
And what skills would be useful for team members to have?
That's a little harder to say. Don't want to presuppose what skills the teams should or should not have. We encourage you to look over the challenge requirements, look over the information that's being presented here today, and make your team selections accordingly.
And what details can you share about the simulation environment right now?
Not too many details at the moment that we can share, apart from what the JSC team has already described. More information will be coming prior to the release of the simulation software. We know that you have questions about it, and we'll get you that information just as soon as we can. At this time, we're going to go ahead and proceed to the Q&A chat box. I'm going to ask that Angela ask the questions to the team here on the line and ask appropriate individuals to respond to it. For everyone on the line, if you have something to add to it, please feel free to chime in.
Okay. So there are a lot of questions coming in, and we are trying to make sure we're doing this in an orderly fashion. So if there's a brief pause, it's because we're trying to make sure we're covering what we need to cover. So the first question, will there be any information about robotic models or the environment that can be used before the start of the competition? And I think we kind of answered that already, but I'm going to push that over to the JSC team to reiterate some of those important dates. JSC, are you there?
Sorry, go ahead.
Will there be any information about robotic models or environments that can be used before the start of the competition?
No.
No, only the information that we provided in January as far as the robotics package will be given out to competitors.
And that was mid-January, correct?
That's correct.
Okay. All right. Let's see. What is the format for challenge submissions interacting with the simulation software? Is it simulated LiDAR or RGB? And that's back over to the GSC team.
So this detail will be provided in the mid-January timeline as far as what type of sensors and what type of capabilities do all the robots have and the characteristics of each.
Thank you. Will phase 2 be using the first generation of ROS or ROS 2?
It will be using ROS, regular main ROS, not the secured one, ROS 2.
Okay. And I think this is something that we had talked about yesterday as well between us, but there's someone that said they would love to get up to speed on how to get started writing code and testing it out. So is there a virtual platform that they can start looking at or something they can use to start playing around with coding?
So, I mean, knowing that ROS and Gazebo will be used in this challenge, people could start learning it themselves, but we are not providing any advanced knowledge about the challenge until mid-January.
Okay. So does the team maintain control of the IP developed for the challenge, or is the IP transferred to NASA at the completion of the challenge? And I can answer that. So the IP stays with the competitors. If you look at the team agreement and make sure you read the IP section, it does detail that information or that IP does stay with the competitor with that team. So NASA does not take ownership of that. NASA does get first right of refusal, so we want to be able to engage with you and talk about if there are next steps for further developing your code or what that looks like. So there is the option for discussions post-challenge, but as far as the IP that you submit as a solution to the challenge, that is yours to keep. Can we add team members or remove team members after the team is registered?
Sure, I'll go ahead and take that one. This question has come up a few times. We're working on some additional guidance for you regarding the changing of team composition. We don't have that information finalized just yet, but as soon as it is available, it will be posted on the challenge page, likely in a forum post and probably in the FAQ as well. So please stand by for that.
Okay. All right, just 1 second. Can we use the NASA meatball logo for the team website? In short, no, you may not. There is, if you notice in the corner of the screen, there is a Space Robotics Challenge logo that you are free to use. and Shaka, jump in if that's not correct, but I believe that's correct, that you can use that logo on your promoting of the challenge and promoting of your team. Feel free to use that. That is what it's there for, but please do not use the NASA meat ball. Let's go number 36. What are some specific responsibilities of the team lead?
Well, the team lead is first and foremost the primary point of contact for the team interacting with the challenge. Questions regarding team eligibility, team insurance, and registration should come from the team leader. The team leader is responsible for collecting all of the necessary documentation and paperwork from all team members. Also important, should that team be awarded prize money, the prize money is delivered to the team leader, not to the team collectively. So that's another important responsibility for the team leader.
Are there any restrictions on team size? I'd say absolutely not.
No, there really isn't a restriction on team size. If you're a team of one, great, fantastic. If you've got a team of 20, also good.
And I think phase one had a team of almost 40 people.
Mm-hmm.
So that was probably the largest team I've seen, but no restriction there.
And don't feel like you are obligated to make your team be fairly numerous. Teams that did well in phase one tended some of them were on the smaller side.
Okay, so JSC, we're going to come back to you. What programming languages can be used for the API in this competition?
It will be mainly C++, Python, Ruby. But ROS does provide a ways to use different languages. So we're not saying you have to use Python or C++. It depends on how you want to create the plugins and code. So we're not restricting on the languages.
Okay. Will the URDF files be provided?
Yes.
Okay. Will the resource locations be given for the qualification round just to verify that the team is finding all of the available resources?
For the qualification, the resource location will not be provided for the final run, but when you guys doing troubleshooting, you should be able to find the location while using the sensors and capabilities that the simulation offers.
So in the qualification round, will competitors be able to alter their robotic system or customize?
They will have some flexibility, but for the qualification, no. Everybody's gonna get the same kind of capabilities. For competition, it's up to them because there are rules for power usage, consumption, and that will make them want to use less power. And so it depends on what they like to do.
However, teams will not be allowed to create their own modifications. They will have to select from kind of a list of components and robotic platforms that we provide. We're not allowing anyone to come in with their own designed robotic systems to do this challenge.
Thank you. Can we assume that the gazebo environment will be photorealistic, similar to the quality presented by OSRF and NASA Ames team last year?
So it won't be as realistic just because the main focus of this competition is to have a autonomous multi-robot system communication, so that is not the main priority.
Okay. Thank you. Or I think we may have already addressed this, so I apologize if I'm repeating myself. What types of sensors will be available? For example, are LiDAR available?
So we've already answered that, mid-January.
Got it. Thank you. Will the non-US teams be funded for travel for the competition round? So since it's a virtual competition, there's no need to travel. However, there will be a winner's announcement event at Space Center Houston in Houston, Texas, that is optional. If you do want to come, we would all love to meet you in person and have you participate in that event. If you speak with any of the Phase 1 competitors that attended the final winners event, it was a really great weekend. There was a cool opportunity to meet each other and to really collaborate and learn from your colleagues. But it is not required. So if you do want to travel, we would encourage you to set aside some of the prize money perhaps, or maybe make arrangements for that through a sponsor or some other means.
As Angela is looking at the questions that are coming in, let me again say, if you've got questions for the challenge, please take this opportunity to submit your questions via the Q&A chat box. We've got a great number of questions coming in, and that's wonderful to see. Given that we are coming up on our hour, I do not expect us to be able to get through all of the questions today. Nevertheless, please feel free to submit your questions via the Q&A chat box, and we'll do our best to get through as many of them as we can.
And we'll leave the chat box open for a few minutes after the webinar has ended to give people a chance to submit any last-minute questions that they'd like us to take offline and answer.
Certainly.
So the question that just came in, the first part we've answered. So are you able to configure different robots for the qualifier? And JSC, please correct me if I'm wrong, but I believe the answer there is no. Everyone will have a set group for the qualifying round. That's correct, yes?
Yes.
Okay, and then the second part of that question, is there a max number of robots that can be used in the competition round?
So there is a mass restriction. So as long as they meet that restriction, yeah.
Okay. Are resources being identified based on visual perception identification or something else, like an electromagnetic signature or some other feature?
We'll provide a custom sensor that will detect such volatile.
Okay. And I think we did already address this. I believe, Kim, you answered it, but just let's take this as the last question and we'll finish up here just to get people thinking about preparing. But where is it recommended that competitors go to look at tutorials or papers and just prepare for the competition?
So the Open Source Robotics Foundation has great tutorials for both the Robot Operating System, or ROS, and Gazebo. And I believe if you just Google ROS and Google Gazebo, they will come up as the first links, and we'll give you lots of tutorials to learn how to use both.
Great, thank you.
Great, okay. So, as Angela and I have said, if we didn't get to your question today, don't worry. We are keeping track of all the questions that are coming in, and let me assure you, there is a great number of questions that are coming in. We just simply didn't have time to get through all of them today. We have all of those questions recorded, and we'll get you answers to those questions as part of the transcript. So I'd like to thank everybody on the line for answering questions today, and I'd like to thank all of our attendees for asking some really great questions. Look for detailed information to come following today's webinar. So I'm going to turn it back over to Shaka from Space Center Houston to wrap things up today, Shaka, what can our attendees do next?
Okay, well, for additional information, again, we encourage you to visit the challenge site, register to stay connected and participate in the challenge forum. And please make special note that the deadline for registration is December 20th, 2019, 5 p.m. Central Time. It's where I live. That's why it's Central Time. One last reminder that this webinar was recorded and will be sent to the team leaders along with the transcript. Thank you for attending, and thank you to our speakers for their time and expertise. We appreciate your time and look forward to the next phase of the Space Robotics Challenge. Have a great day, everyone.
And just for one last reminder for anybody listening to today's webinar, if you have any questions or concerns, please feel free to reach out to the Challenge Help Desk. Contact information is there on the screen. The email is info@spaceroboticschallenge.com. There's also a phone number, area code 216-283-3901. Given some of the complexity of the questions that you all have, I tend to suggest that you submit your questions via email. That way you can include all of the complexity and details of your question, and we can get you a fully comprehensive answer. I'll keep the Q&A chat box open for just a couple of minutes longer because I know we've got some additional questions coming in. In just a few minutes, I'll shut that down. And if you have any questions post-webinar, again, you know how to get a hold of us. Thank you very much. Have a great day, everybody.